Hello, everyone, and welcome to another episode of C2MCI HQP Highlight Series, where we showcase the research, experiences, and perspective of trainees across the C2MCI network. My name is Hetvi Shah, and I'll be your host for today's conversation. Thank you for being here with us today, and let's dive in. Today, we're excited to speak with Thilini Malsha Suduwella, a PhD student at McGill University under the supervision of Professor Janine Mauzeroll. Her research is affiliated with C2MCI, where she's primarily working on a macro scale project focused on studying NHC coatings on steel as corrosion protection coatings. Thank you, Thilini, for joining us today. We're so happy to have you here.
Yeah, thank you so much for the invitation and having me.
Okay, so what first drew you to your field of research?
So, I grew up in Sri Lanka in a coastal area, and everyday life I experience corrosion closely because in coastal area everything made with metal are corroding, and I always wonder, is there a better solution for corrosion? I think that curiosity drives me towards the science and eventually what I'm doing today, where I'm studying in heterocyclic carbines as a corrosion protection layers on mild steels.
That's really cool. And it's so nice to have like a personal story that drives you. I feel like you need that passion to show up for research every day and keep pursuing it. Okay. So now that we know a little bit about your research, what's the coolest analytical or synthetic technique you've learned recently? And why did it excite you?
I think it's AFMIR, atomic force microscopy infrared spectroscopic technique. It is a hybrid microscopic and spectroscopic technique. I think it's much fascinating to my field is because I'm mainly focused on the surface phenomena, and it is always important to have a very sensitive surface technique. And in AFMIR, we are doing the analysis with the AFM tip, which is in nanometer scale. So it gives high surface sensitivity and a good technique for my research.
It's really cool. I think I've heard about it, but I always only hear the acronym and I never know what it actually is. So it's actually good that I finally learned what it actually means and how you use it. So that is really, really cool. And now this next question is going to be a little tricky. What are your research projects with C2MCI that you're most proud of? And what makes it special? I know it's like picking a favorite child, but hopefully we have one.
I think it's my recent project where we worked on functionalization of carbon surfaces with N-heterocyclic carbene for a couple of reasons. One is the metal carbon bond between N-heterocyclic carbines and transition metals were well known. Even before it was applied for surface functionalization agents, it has been studied as ligands for transition metal catalysis. But the NHC attachment to carbon surfaces only studied recently. In our study, for the first time, we showed the feasibility of electrochemical deposition of NHCs on carbon. And more importantly, we studied and we showed the stability of NHCs on water, aqueous media, which has not been studied before, as well as the feasibility of NHC deposition in aqueous media. So I think that finding is remarkable enough to be proud of.
No, that's amazing. And I mean, any work done towards a project and your PhD is always something I think to be proud of. So that's really exciting that you get to see this kind of come to full circle and fruition. So that's really cool. Moving on from the talks about the project and more about the people you get to work with. Have you ever worked with people from different disciplines and how do you make the collaboration effective?
I would like to start with my group itself. We are a mainly electrochemistry group, but in our group, we are working on different fields such as corrosion, batteries, biosensors, as well as computational and simulational studies. So, in that case, every day we work with people with different perspectives. I find it more helpful in a way that when we're looking at a research problem, when we are presenting our work at a group meeting, we always get a feedback from different perspective, which helps us to see the problem in different ways and find solution in different fields and techniques and methods. And one thing is that working with different disciplines is like communication. So you have to always communicate better and explain your expertise well to others.
Yeah.
That makes it more workable environment.
I definitely agree. I feel like it's such a privilege to have many people with different experiences and different breadth of experience to really kind of come and support you through and just might give you that one different idea that you might not have thought about by yourself. So that's definitely really helpful, especially in research. With that, now have you ever mentored or trained someone? And what did you learn from that experience?
Yes, actually, last year I had a privilege to mentor an undergraduate student who is a visiting scholar from Japan, and I always wanted to be a teacher, but I
Wow.
never get a chance to work closely with someone. So this was an opportunity for me to mentor a student. One thing is like I learned from that is that I enjoyed that experience, and from her feedback also I get to know that I did a good job. Also, I like the way that I was able to teach something, a technique, or how to plan an experiment. And also, I always like to give them a chance to come up with ideas than micromanaging my students. So it was a great experience.
No, I have a summer student right now, and it's really good to learn those skill sets and to like be able to teach them. Just have to do research. I feel like there is no right way of doing research, so to be able to teach that and learn from it, I really enjoy that side of being a grad student as well. Okay, so now moving on to your different skill set, which is your communication skills. Just tell us about a presentation or a poster session you gave and what made it successful.
I'm a person who likes to present posters more. I know
Oh,
it's a
wow.
general preference, but I think it's because I can have more specialized talk. So in a poster, you always interfere with your audience or the person who visit your poster and get to know what they're more interested on and get to know their expertise so you can explain your project more a better way than a presentation where you present it to a more like a general audience. And also in a poster you get a feedback uh, with different people closely than in a presentation where only the audience get 2 3 questions. It's just my personal preference. Yeah.
That's fair. That's fair. No, I definitely am an oral presentation person, so it's good to see a different perspective on personal presentations. Hopefully, maybe I'll try to keep those things in mind when I have a next one to maybe enjoy it a bit more moving forward. Okay, so how do you prioritize tasks when juggling multiple projects or deadlines?
I think it's a learn and fail process at one point. But when I'm starting my PhD, I was a new mom, so I start with PhD with a young child. So I always had to juggle my responsibilities, even as a mother and a researcher. One thing I was successful is because I had a support from my husband as well as especially my supervisor, who really understood me and helps me throughout the process. Like one thing I learned is like it's better to plan either your week or at least the next day a night before and try to stick on the schedule so it might help plan your day and achieve the deadlines. But it's trial and error.
I hear you. I live by my calendar. Okay, so I think now that we know that you have such a busy schedule and you have so many things to juggle, how do you come up with new ideas or methods for your work? How do you let the creativity and problem solving take place in your day-to-day life?
I always like to search on literature because we can find a lot of new things through literature. And also, I have a master's from redox flow batteries where I worked on synthesizing organic materials for redox flow batteries. And I think my experience in that field is also helpful me finding techniques or came up with ideas in my PhD as well. And also I like to talk with postdocs and my colleagues at the group, which helps me if I'm failing with something to come up with idea. I think that helps me.
For sure. No, those are some definitely good ways to just get your creativity flowing and spark some new ideas. Now we're gonna go get to know you a bit more. And so I want to know what's your favorite chemical element or molecule and why is that?
There's no like very big reason for that. It's just I find iodine is interesting because it's purple in color. I'm obsessed with purple. So that's
That's a very valid reason. It is a beautiful color. I agree. If you could turn any chemical reaction into a superhero power, what would it be and why?
I think I'm biased. I think if metal deterioration, like metal oxidation or corrosion, can become a superpower, I would like it to be not deteriorating the material, but to increase its strength and make it better than making it worse. Yeah.
That that's a very unique superhero power. It was very, very driven by your research. I really like that.
Maybe my personal experience as well.
Yes, that's true. That's true. What is one thing about your research that consistently makes you smile or surprises you?
Well, I think it's every day I get to do something new and explore something new that no one has ever found out or studied. So I think it's very fascinating and I really love that thought.
That's really and that's fulfilling as well. I will remind myself that when I'm having a rough day with science. Thank you. Lastly, this is to what's one piece of advice you would give to someone who's just starting their journey in chemistry?
I think always stay curious about things happening. And I think to be a better scientist, you have to be curious why it happened and why it goes wrong, all these things. So I think to be a scientist, you have to be curious and you have to enjoy what you are doing. I think it makes you a better scientist.
I definitely support that as well. Well, thank you so much for taking the time to answer my questions today. I can't just wait to see all the new cool things you're doing.
Yeah, thank you so much for the opportunity.
Absolutely. Thank you again, Thilini, for joining us and sharing your work and experiences. To stay up to date on future HQP highlights and other C2MCI activities, be sure to follow our LinkedIn page and other network channels. Thanks for watching, and we'll see you in the next episode.